Chapter 1, Exercise 9. Hints. Verify axioms of an order from definition 1.5. Consider a set A equals bi, b element of real numbers. Note that this set is bounded from above in a lexicographic order, but does not have a least upper bound. Solution. We need to show that order axioms from definition 1.5 are true for the lexicographic order on the set of complex numbers. To verify property I of definition 1.5, consider complex numbers z equals a plus bi, w equals c plus di. If a less than c, then z less than w. If a equals c and b less than d, then z less than w. If a equals c and b equals d, then z equals w. If a equals c and b greater than d, then z greater than w. If a greater than c, then z greater than w. Relations z less than w, z equal w are inconsistent. Indeed, if z less than w, then either a less than c or a equals c and b less than d. In each case, z not equal to w. Similarly, relations z equals w, w less than z are inconsistent. Relations z less than w, w less than z are also inconsistent. Indeed, if a less than c or a equals c and b less than d, then w not less than z. So, for any complex numbers zw, one and only one of the statements z less than w, z equals w, w less than z is true. To verify property II of definition 1.5, consider complex numbers z equals a plus di, w equals c plus di, v equals e plus fi, such that z less than w and w less than v. Note that a less than equal to c and c less than equal to e. If a less than e, then z less than v. If a equals e, and a equals c equals e, and b less than d, d less than f. It follows that b less than f and z less than v. In any case, z less than v. Consider the set A equals bi, b element of real numbers. For any c greater than 0, bi equals 0 plus bi less than c plus 0i equals c for all b element of real number. So the set A is bounded from above. Let c plus di be an upper bound of A. Since d plus 1 times I, element of A, and d plus 1 times I less than or equal to c plus di, it follows that c greater than 0. Further, c over 2 is also an upper bound of A, and c over 2 less than c plus di. There is no least upper bound of A in the lexicographic order on the set of complex numbers. Comments. If A, C, and R, then the relation A plus 0i less than C plus 0i is equivalent to A less than C. So the restriction of the lexicographic order on the set of complex numbers to the real line R is the usual order on R. We obtain an example of an ordered set without the least upper bound property that contains a subset with the least upper bound property. Thanks for watching.